In this video, we're going to explore why any base value taken to the power of 0 will give us an output of 1. We're going to explore this with 3 different examples. We'll spend some time with 2 to the power of n, and then quickly move through 4 to the power of n and a base of -5 in parentheses taken to the power of n. So looking at 2 to the power of n, what we're going to do is we're going to show our exponents or powers that we're more familiar with. We're going to start with 2 to the power of 1. We're going to look at 2 squared, 2 cubed, and 2 to the power of 4. We're going to look at these in expanded form. So 2 to the power of 1 is going to be 2. 2 squared is going to be 2 times 2. 2 cubed is going to be 2 times 2 times 2. And we'll follow that same pattern for 2 to the power of 4. Now, when we look at these exponential expressions, we're going to view these exponential expressions in terms of fractions. When we get into negative exponents, we need to remember that a negative sign in mathematics is telling us that we're looking at an opposite. And the opposite of a fraction can be viewed as its reciprocal. So it's a lot of information that we're going to revisit at the end of this chart, or at the end of this slide. What we're going to do right now is just take all of our expanded forms and convert them into fractions by placing them over a denominator of 1. It might look like an extra step now, but it's going to help us identify patterns to predict future outcomes once we start looking at negative exponents. Now, our simplified form of our 4 exponential expressions is simply going to be 2, 4, 8, and 16. And what we're going to do here is we are going to take our final outcome, or our final output of 16, and just visualize taking that back to 8. We would have to divide 16 divided by 2, looking right to left. 8 divided by 2 is going to give us 4, and 4 divided by 2 will give us a quotient of 2. Now, as we move right to left, we're going to take 2. We're going to follow that pattern. We're going to divide that by 2. And that is going to give us a value of 1. Now, working our way up, our expanded form in terms of a fraction, that's going to look like 1 over a denominator of 1. And following our patterns of exponential expressions, 2 to the power of 4, our exponents are decreasing. This is going to be 2 to the power of 0. And now we're going to start looking at negative exponents. All right. So we're going to look at our simplified form first, and then look at our expanded form, and then discuss what is going on when we take a base to a negative exponent and how that affects our base to the power of 0. So we're going to continue dividing our previous outcome by 2, and that's 1 divided by 2 is going to be 1/2. 1/2 divided by 2 is going to produce 1/4, and half of 1/4 is going to be 1/8. Now, in our expanded form, we're still going to have our fractions. It'll be 1 over 2 to the power of 1. When we look at 2 to the power of -2, it's going to be a numerator of 1. 2 to the power of -2 is going to be 2 times 2 is our denominator. And our expanded form for 2 to the power of -3, numerator of 1, denominator of 2 times 2 times 2. Now, negative values are opposites. The opposite of 2 to the power of 2 is going to be 2 to the power of -2. The opposite of 4 over 1, or the reciprocal of that fraction, is going to be 1 over 4. We also see that right here. And we can look at that same example with 2 to the power of 3. The opposite of a +3 is going to be a -3. The reciprocal of 8 over 1 is going to be 1 over 8. Now, as our exponents become closer and closer to 0, we can see our values are going to approach 1. Now, nowhere on this chart are we looking at a negative value. As our exponents become more and more negative, our outputs are going to get closer and closer to zero, but they're never actually going to become equal to zero or ever become less than zero. Now, we're going to look at this chart, two more examples, except we're going to go a lot faster on these next two examples. We're going to look at 4 to the power of n. And same process, we're going to take a base of 4, take it to the power of 1, power of 2, power of 3, and power of 4. Our expanded, and we're going to skip the expanded form. We know the simplified form of 4 to the power of 1 is just going to be 4. 4 squared is 16. 4 cubed is going to be 16 times 4, which is 64. 64 times 4 will produce 256. And as we start from 256 and work our way backwards, we're always dividing by 4, dividing by that base. And 4 divided by 4 is going to produce 1. 1 divided by 4 is 1/4. 1/4 divided by 4 is 1 over 16. And 1/16 divided by 4 is going to be 1 over 64. All right. Now we'll look at our bases with our exponents, working right to left. We'll get to 4 to the power of 0, 4 to the power of -1, 4 to the power of -2, and 4 to the power of -3. And once again, we can see that as our exponents become more and more negative, our outcomes are going to get closer and closer to 0, but they're never actually going to reach 0. They're never going to go below 0 or become negative values. And once again, we can also see that when our base is taken to the power of 0, our outcome is going to equal, or output is going to equal 1. All right, one last example. And this time we're going to take a look at a base that's a negative value, which is going to make things a little bit different here. So we have -5 to the power of 1, -5 in parentheses to the power of 2, -5 in parentheses to the power of 3. Our simplified form, let's see, -5 by itself is going to be -5. -5 times -5 is going to become a positive 25. -5 times -5 times -5, or positive 25 times -5 is going to become -125. If we work right to left, we're dividing all of our outcomes by -5. -5 divided by -5 is just going to become a positive 1. 1 divided by -5 is going to become 1 over a denominator of -5. I know I could put that negative sign out in front. I want to keep that negative sign on the denominator to show a pattern here. And as we look at our exponential expressions, always keeping that -5 in parentheses, we have -5 to the power of 0, -5 to the power of 1, -5 to the power of, -1, -2. And as we look at this in expanded form, we will see that our fractions are the opposite of our integers. Like so. And anything taken to the power of 0 is just going to be a fraction of 1 over 1, or just 1 by itself. So hopefully these charts and these examples help demonstrate why any base taken to the power of 0 is going to give us an output of 1. If our base is a positive number, like it was with +2 or +4, our outputs will always be positive. As our exponents become more and more negative, our outputs are going to get closer and closer to zero, but they're never going to cross below zero, and they're never going to be equal to zero. All right. And hopefully these examples help explain what is going on with negative exponents, what is going on with a power of zero. And I think it's helpful to look at these negative exponents in terms of fractions rather than negative numbers.